Gokul sir, good afternoon, sir.
Good afternoon, madam. Am I audible?
Yes, sir.
Thank you.
Sir, 30 participants joined it. We shall wait and start the session exactly at 2 o'clock, sir. Okay, sir.
Sure.
What's the time there, sir, now?
It's 8:20, madam.
8:20 morning. Okay, sir. Okay, sir. We shall start at 2 o'clock, sir.
Sure.
Okay, sir. Okay, sir.
We'll resume by no.
Good afternoon, Vijendra sir.
Good afternoon, ma'am.
Okay, sir. Welcome to the session.
Thank you.
Gokul sir, shall we start the session, sir?
Yeah, sure, ma'am. Am I audible now?
Oh, yes, sir. Yes.
Thank you. Thanks, madam. I'll
Okay, sir.
share my screen.
Okay, sir. I'll give an introduction, sir.
Yes, sure.
Dear participants, I welcome you all for the afternoon session of day 1 of 1 week International FTP on Trends and Innovations in Industry 4.0. I invite Mrs. J. Shamila Devi, Assistant Professor, Department of ICE, AVC College of Engineering, to introduce the eminent speaker of this session.
Good afternoon, everyone. To start with our afternoon, I'm very delightful to welcome our eminent speaker, Mr. Gokul Rajendran, for 1 week International Online FTP on Trends and Innovations in Industry 4.0, organized by Department of Instrumentation and Control Engineering. I especially thank our placement officer, Dr. P. Balasubramaniam sir, for introducing such eminent person, Mr. Gokul Rajendran, to us. Let me start with the words of Albert Einstein. Imagination is more important than knowledge. Therefore, the true sign of intelligence is not knowledge, but imagination. When we apply this imagination, we could create many innovative things for our future development. With this, I would like to introduce our speaker, Mr. Gokul Rajendran sir. He is a prestigious alumnus of our AVC College of Engineering, belongs to Department of Mechanical Engineering. He is currently working in UK public sector as senior DevOps consultant. He has been working in IT and ITES for last 15 years in companies like Infosys, HP, and Cognizant Technologies. I cordially invite to share his thoughts in the topic Industry 4.0, future work and job opportunities in IT and ITES. I welcome you, sir.
Thank you. Thanks a lot, Shamila ma'am. Thank you, Surya Prabha ma'am. I'm sharing a screen to start with. Just let me know when you're able to see my screen, ma'am. Is the presentation slide visible?
Yes, sir. Visible, sir.
Right. Thank you. Just give me a moment. Yeah. Good afternoon, everyone. I'm Gokul Rajendran. As ma'am introduced, I'm a proud alumnus of AVC College of Engineering. I completed my mechanical engineering back in 2007 from AVCCE. First of all, I would like to thank my mother for making me the person all I am today. She herself was a school teacher for about 14 years, so I have a huge respect for the entire teaching community. And thank you all for giving me this opportunity to interact and share my thoughts with such a learned and diverse audience like this. As majority of my audience are going to be lecturers, professors, assistant professors, and this being an afternoon session, I don't want to bore you with too many definitions and terminologies, which you either already know or can Google it with a touch of a button from your smartphones. There will be some definitions and background for the benefit of wider audience though. So rather based on stats and survey reports, I would like to discuss about the trends in Industry 4.2, the kinds of jobs that have evolved around it, the demand for such jobs, how good is the latest syllabus of an university in line with the industry expectation, how can students make use of their time in college to equip themselves to be ready for the job market. So I will also touch upon slightly about job opportunities abroad. And there was an excellent session in the morning by engineer Jamin Santiago. I hope you can take away some of these info from my session to pass it on to your students to motivate and guide them better. Yeah, so just to give a brief on what Industry 4.0 is. So we've seen a lot of industrial revolution. So the first industrial revolution starting in late 18th century in Britain. It helped enable mass production by using water, steam power instead of purely human and animal power. So finished goods were built with machines rather than painstakingly produced by hand. And the second, a century later, the second industrial revolution introduced assembly lines and use of oil, gas, and electric power. So these new power sources, along with more advanced communications via telephone and telegraph, brought mass production and some degree of automation to the manufacturing process. The third industrial revolution, which began in the middle or late 20th century, added computers, advanced telecommunications, and data analysis to manufacturing processes. So the digitization of factories began by embedding the programmable logical controllers, the PLCs as you say, into the machinery to help automate some processes and collect and share data. Coming to the fourth industrial revolution, we are now in the fourth industrial revolution already, also referred to as Industry 4.0. Characterized by increasing automation and employment of smart machine and factories. Informed data helps produce goods more efficiently and productively across the value chain. So flexibility is improved so that manufacturers can better meet customer demands using mass customization, ultimately seeking to achieve efficiency with, in many cases, a lot size of one. So by collecting more data from the factory floor and combining that with other enterprises, operational data, a smart factory can achieve information transparency and better decisions. So as you see in this slide, it is the current era during which the fourth industrial revolution is taking place with emergence of high-speed internet and industrial internet of things. So this industrial revolution directs towards new technology advancements. Today, the industry aims to connect all production means to enable interaction in real time. And this is possible due to technologies such as cloud computing, big data analytics, and Internet of Things, as explained very well by engineer Jamin Santiago earlier today morning. So these step-by-step development are gradually enhancing production tools and revealing endless possibilities for the future of the industry through an interconnected global system. And this revolution also has turned towards greener sources of energy such as sun, wind, and geothermal. We'll take a quick deep dive on these technologies. So this is a broad classification of technologies that Industry 4.0 is based on. Though there are these many technologies, the key ones that are taking the world by storm are just 6 of these as of now. And I'll try to refine my speech around one of those. So these are the 6 topics as I said, is more popular nowadays. And Internet of Things, Engineer Jamin Santiago explained this very well in the morning session earlier today. But I will give a quick overview of this and other key tech just for the benefit of new and wider audience. The Internet of Things, IoT as it's called, is a key component of smart factories. Machines on the factory floor are equipped with sensor that feature an IP address that allows machines to connect with other web-enabled devices. So this mechanization and connectivity make it possible for large amounts of valuable data to be collected, analyzed, exchanged, and based on that data, it automates another process. And coming to cloud computing, so this is going to be my topic, my topic of the session for today. And rather than just explaining what is cloud computing, I would like to share my thoughts on where the industry in terms is heading in terms of adoption, use cases, job opportunities, which can help you educate and motivate your students. So cloud computing is a cornerstone of any industry 4.0 strategy. The full realization of smart manufacturing demands connectivity and integration of engineering and supply chain, production, sales, distribution, and service. You name it, it's all there. So cloud helps make that possible. In addition, the typically large amount of data being stored and analyzed can be processed more efficiently and cost effectively with cloud. So cloud computing can also reduce startup costs for small, medium-sized manufacturers who can right-size their needs and scale their business as it grows. And the other few topics mentioned here are artificial intelligence and machine learning, edge computing, cybersecurity, and digital twin. So I'll just speak about what they are, and I'm not going to detail much about it. Most of my session would be covering about cloud computing today. So AI and machine learning allow manufacturing companies to take full advantage of the volume of information generated not just on the factory floor, but across the business units and even from the partners or third-party sources. So AI and machine learning can create insights, providing visibility, predictability, and automation of operations and business processes. For instance, industrial machines are prone to breaking down during the production process. So using data collected from these assets can help businesses perform predictive maintenance rather than reactive maintenance based on machine learning algorithms. So that results in more uptime and higher efficiency. And coming to edge computing, so the demands of real-time production operations mean that some data analysis must be done at edge, that is, where the data is actually created. So this minimizes the latency time from when the data is produced to when a response is required. For instance, the detection of a safety or a quality issue may require a near real-time action with the equipment. So the time needed to send the data to enterprise cloud and then back to the factory floor may be too lengthy and depends on the reliability of the network as well. By using edge computing, it also means that data stays near its source, reducing the security risks involved in transferring it between the cloud and the equipment itself. And coming to cybersecurity, manufacturing companies have not always considered the importance of cybersecurity or cyber physical systems. However, the same connectivity of operational equipment in the factory or field that enables more efficient manufacturing processes also exposes new entry paths for malicious attacks and malware. When undergoing a digital transformation to Industry 4.0, it is essential to consider a cybersecurity approach that encompasses IT and OT equipment. And coming to digital twin, so the digital transformation offered by Industry 4.0 has allowed manufacturers to create digital twins that are virtual replicas of processes, the production lines, factories, supply chains, everything. So a digital twin is created by pulling data from the IoT sensors, devices, your PLCs, and other objects connected to the internet. So manufacturers can use these digital twins to help increase productivity, improve the workflows, design new products. But by simulating a production process, for example, manufacturers can test changes to the processes to find ways to minimize the downtime and increase capacity. So till this point, is this okay? Can I proceed further? Are there any questions?
You proceed, sir.
Right. Just want to make sure the screen is shared well.
Shared well,
see
sir.
the presentation on full screen.
Shared, sir. Everything okay, sir.
Is it on full
sir.
screen? Okay.
Okay, sir. You proceed, sir.
Yeah. So I just want to give a quick overview of the cloud computing architecture. As I said, the main topic of the day for me today is cloud computing architecture, because I don't want to dilute this conversation by covering all the topics. I just want to concentrate on one as of now. Maybe in a later point of time in the months to come, I can speak more about others in other sessions. But today, cloud computing. So it's the system of databases and software, typically operated in data centers and warehouses. So it enables users and business to access the digital information over internet from anywhere, rather than having physical servers in a network in a network closet in a back office. Cloud computing offers businesses reduced IT overhead cost, which is especially important for small businesses and startups that might not have that capital to invest in an extensive on-premise IT department. So nearly every aspect of life involves interacting with cloud technology, whether as a consumer or as an IT professional. On the consumer side, reduction of physical media such as CDs, your DVDs, your video games, all this has led to the rise of an on-demand streaming services, and this requires remote storage options that can support large amounts of data to be delivered accurately and immediately. In the IT field, advancements in AI, machine learning, and IoT compatibility have driven enterprises to seek the agility and flexibility that cloud offers. Moreover, cloud computing is rapidly growing IT field in need of skilled professionals. So a quick comparison between what a traditional model of operation would look like as compared to cloud model. So in traditional model, most companies are running custom applications that are stitched together. They have purpose-built hardware to think about and have specialized teams, and everything has been carefully customized over many years in some cases. So this is of course done for all the right reasons, but you might consider that it might be holding your business back in many ways, given that the business context has changed fundamentally. In this new age of apps, the traditional model causes friction because IT isn't moving as fast as the business wants it to. So this is manifested in the developers not getting the speed and freedom they need to create the best end user experience. That leads to lots and lots of lost productivity on their side, which results in a shadow IT. In 2015, 42% of technology budget resided outside IT. So this is going to grow to about 70% by end of 2023, as per a Gartner report. Coming to cloud model. So now let's look at the cloud. Everyone knows that cloud offers agility and innovation. It's proving itself to be the way forward for modern enterprise. And we'll talk a bit more about that. But for some of the IT customers, the cloud might seem a little daunting. They might be asking, is there something I want to lead the charge on? How does it help my career? The tension it's the tension some of them experience is because you are not sure if things are consistent with what you are doing on premise, and it seems like it will be hard to manage. There is also a tension between the developers who want speed and freedom represented by the business demands, obviously, and the IT folks who have to worry about things like security and compliance. That, as listed in this slide, these are the main differences between the traditional model and the cloud model. In traditional model, you have a dedicated data center, and in those data centers, you will have your own servers connected to your backend storages, your own network. So these are all purpose-built hardware just to host your application. So, for example, just imagine if Amazon.com or a Flipkart application is hosted in a traditional model. So that would have been Amazon or Flipkart having their own data center, having their own hardware. It will be distinct infrastructure and operation teams, as mentioned in this slide. They will have a dedicated team to maintain their own data center and all the hardware, power, cooling, everything. And they will have their own customized processing configurations. Just switch to cloud model. Just imagine that Flipkart is an application which is hosted in a cloud rather than a traditional model of a data center. Then it will be loosely coupled apps and microservices, as they call it, because in traditional methods, you used to have applications they call it monolithic applications, because all your software is just embedded in one single package. Even if you have to change only one feature of your software, for example, let's say Amazon.com is there, and you have the search bar in Amazon to look out for the products. That will give you all the products available. You can type for mobile phone. You can give specific model. It will search for all the related models in the site, and then you click on buy. It will redirect you to the payments page or add to cart. So in a monolithic application, this everything used to be packed in a single monolithic application, so that even if you have to change one feature, for example, you wanted to change the payment gateway from what it is now to a newer payment gateway. You have to bring in the traditional approach, you'll have to bring down the entire application, have a downtime, upgrade it, then bring up the application. So that leads to end user outage. At that time, Amazon won't be able to serve you. You might be getting a 404 page not found or site under maintenance, such messages. And that's obviously going to lead to a revenue loss, as you will have a downtime. And as you know, people are accessing such applications 24/7 now. They're not even having any day or any specific time of the day to access them. So businesses cannot afford to lose such valuable time of the customers. So they have switched to cloud model, wherein these application itself is loosely coupled. When I say loosely coupled, each feature, for example, search bar would be a separate microservice. Add to cart will be a separate microservice. Payments will be a separate microservice. So if you want to just upgrade your payment, you just have to upgrade that part of the microservice, the payments page. Still your search page and your add to cart, all other functionalities will still be working. You won't need a downtime for the entire application. So that's the power that cloud brings to you. That's called as microservices. So while customer can still search and add to cart, he just cannot pay. So that's a very minimal or less downtime in comparison to a monolithic application. So that's the power of the cloud model. That's where the industry is heading, and almost most of the enterprises, the huge corporations, they have adopted cloud. 60% or 70% of huge enterprises have adopted the cloud model, and they are slowly migrating from traditional monolithic applications hosted in a data center to microservices hosted on a cloud platform. And to enable that such cloud model, you need service-focused DevOps teams. When I say DevOps, it's a mix of development and operations. In the early days, in traditional methods, you used to be having two types of job titles. Application developers would be simply called developers, and the system administrator will be normally called as the operations teams or the ops team. But nowadays, it's all merged into a single terminology. So DevOps is not a job title or a role. DevOps is just IT culture. DevOps is a culture wherein both development and operation is handled by a single team, and the engineer who does the job is called a DevOps engineer. Are there any doubts in this slide, or can I proceed further?
When you proceed, sir, participants will ask the doubt at the end of the session, sir.
Okay, madam. Thank you.
Okay, sir.
So there are three types of cloud. In brief, public clouds utilize the shared infrastructure, while private clouds utilize the organization's own infrastructure. As I said, the data centers, their own data centers. Example, Amazon Web Services is a public cloud, Google Cloud Platform, Microsoft Azure. These are the popular cloud providers. And private clouds, sometimes referred to as data center, resides on company's own infrastructure, typically firewall protected and physically secured. Matured organizations that have heavily invested in on-premises infrastructure frequently leverage that investment to create their own private cloud rather than paying for a public cloud. Although this offers a big financial benefit, public clouds must still be supported, managed, and eventually upgraded or replaced. So the onus for security in a private cloud falls squarely on the organization's shoulders, from physical security to encryption on network and cyber security. You name it, everything comes under the organization. So they have to take care of it. Since private clouds are typically owned by the organization, there's no sharing of infrastructure. For example, no multi-tenancy issues, zero latency. These are some advantages of having a private cloud, but the disadvantages outweigh the advantages. When organizations choose to make use of their own data center and also the public cloud, that's where the hybrid comes into picture. So the hybrid is a mix of both public and private cloud. So as I explained to you with the Amazon example, this is how a traditional application lifecycle would generally flow. The developer will build a website. He will host it on a server, and he will save this work on the server. And then comes the administrator, the system admins, who maintain the website, who take a backup of the storage, add storage, and add the compute and network resources for the application servers. And that in turn keeps your application online to be used by the end user, who is the consumer. So to name a few use cases, rather than just detailing about cloud computing and its advantages, I thought of talking about a few use cases. They call it as SaaS in short. So a lot of corporations have embraced this new cloud computing model, and they are now providing software as a service. So you don't have to build a software or maintain your software yourself. Rather, you just have to consume the software as a service from an external provider. And you have the big data analytics, software-defined networking. So in earlier days, the networking used to be completely hardware-driven, but now a lot of those networking hardware has been converted into code. So as infrastructure as code and a software-defined code. These are also some good use cases of cloud computing. And infrastructure as a service. For example, I'm starting a new business, and I want 3 servers, one application server, one storage, and one database server. If that is the case, in a traditional method, I would have to plan for the servers, a place to host, the network connectivity, the internet, and all the physical security, everything I have to plan for, and I'll have to purchase them. There is a capex involved, a capital expenditure, the initial cost of buying those hardware, and you'll have to maintain it. Again, you cannot buy it on the day you plan it. The planning itself will take around 2 to 3 months. How many servers do I need, and how much would they scale? So all these things would have to be planned well in advance, maybe 3 months, or bigger corporation 6 months. And what application am I going to host on those servers? So these things took a lot of time in earlier days. But with cloud computing, this is all become very easy. And I can just run a couple of servers or even hundreds of servers based on demand. So if I want 10 servers tomorrow, or just I can plan it for today. If I create an Amazon Web Services account and I pay for it, I get the servers with whatever desired configuration I want in a matter of minutes. So you are saving a lot of time, you are saving a lot of effort, you're saving a lot of power, people involved in maintaining them, and you just have to pay for the time you use. For example, if I want 3 servers for 3 hours on every Friday, 10 p.m. to 12 p.m., that can be done. So that's the level of flexibility the cloud offers. And you can run your application based on demand. You can scale up, scale down, everything can be done through cloud. So that's where infrastructure as service comes into picture. So these cloud providers, this AWS, this Google Cloud Platform, Microsoft Azure, these cloud providers provide you those infrastructure. When I say infrastructure, it is the servers, the networking, all the hardware. So those hardwares will be hosted in their own data center, but through internet, we can access them. So that is called as infrastructure as service. And you can also similarly have backup as a service, disaster recovery as a service. Disaster recovery is one of the very popular service being used because you won't know when your organization would be hit by a cyber attack or by a antivirus, for a malware attack or anything like that. So in that case, a lot of your data can be safely backed up and stored in multiple zones and replicated across zones, across nations, so that in case of an attack, you can restore all your data and server and services back quickly. Again, the email is almost all of the email providers have migrated to cloud. Nothing is running on-prem. And virtual desktops. So you don't have to have your bulk CPUs at your home. You just need a monitor and like a thin client and a internet connection. You can still have like a Mac OS or a Windows OS accessed from that thin client. So that's virtual desktops for you. And a lot of IT organizations use this VDIs, virtual desktops, and that is also called as DaaS, which is desktop as a service. So you don't have to invest in buying a desktop. You can just use that service. Like if you want to use it for 30 days, just use it, pay for it, close your account. You don't have to invest, own it, and do the maintenance. Likewise, test and development. So these are the common cloud computing use cases, I would say. But this is not limited to this. There are, I would say, almost 100 services like this, which is offered by the cloud across the different cloud providers. And you can see in just this picture, if there is one picture that can bring all of us to reality and make us feel the importance of learning and upskilling, it is this. We need to keep upskilling and cross-skilling ourselves in all the relevant fields of work. That's what Industry 4.2 has brought upon us. You can clearly see that nowadays there are no helicopters flying. In a matter of 10 years, if the cameraman and the pilot have lost their jobs, just imagine what's going to happen 10 years from now. So whatever job that's seemingly relevant now can be totally irrelevant in a matter of 5 to 10 years. So that's how fast or how quickly the technology is evolving, and the new tools. There are some tools like ChatGPT, as mentioned by Jameen. Those are just mind-boggling. If you just read about ChatGPT, if you just start using ChatGPT, you will come to know how fastly it's evolving. So this is where I wanted to insist mainly, not just the teachers, but the students. To be honest, they need to upskill and cross-skill themselves. The syllabus, just the syllabus, will not be sufficient. But I'll come to the syllabus part next, which is quite interesting. But this is a message I wanted to convey. And if you want to pick up on one specific skill, which is not going to, get outdated in a matter of 10 years, it's going to be cloud computing. So that's why I picked cloud computing as a topic today. Yeah, and as you said, cloud computing is changing everything about IT skills. And here is what that means for our traditional jobs. And when I say jobs, I'm not just referring to IT jobs, I'm referring to non-IT jobs as well. As businesses switch to cloud computing, the demand for some traditional IT roles will plummet, but new different jobs will be created instead. Multi-cloud is increasingly winning favor among the organizations looking to diversify their technology stack. And they pick and choose cloud computing services from different providers according to their needs. For example, one organization can have both Amazon Web Services and also Google Cloud Platform, and they can also host it in Microsoft Azure. So if there is a downtime in Microsoft Azure, their services which are replicated in Amazon Web Services will still be running. So this is called as a multi-cloud tenancy. Like, so much change happening so fast, and even non-IT employees will also require better knowledge of cloud tools, particularly as remote working becomes commonplace. A recent report by Amazon Web Services found that cloud dominated the list of key digital skills employers say will be the most in demand by 2025. And yet it found that just 45% of workers have trained or are in cloud skills. So automation changes the entire mindset of IT organization, particularly the infrastructure and operations organization, where they need to stop being administrators and become programmers. These are two completely different skill sets. So that tells you a lot about upskilling, not just upskilling in your own tech, but cross-skilling in other techs as well. And coming to low-code and no-code tools, that is the latest improvement. For example, it has become a favorite among the businesses that need to get products and services onto the cloud quickly. A Gartner report believes this popularity will continue and predicts that the use of low-code or no-code tools, it will triple by 2025. These low-code or no-code tools, when I say low-code or no-code, you can quickly write a software or create a software with no code at all, just by giving your requirements or very minimal codes. So there are so many tools in the market like that. That's what I'm referring to as low-code or no-code tools. So these may prove to be useful assets for administrators juggling multi-cloud environments, but this doesn't necessarily equate to a downturn in need for additional software development and coding skills. And these are some stats I wanted to share with you. So in 1919, Salesforce.com, it was initially called as Force.com. It launched its first ever software as a service product. And in 2016, Amazon Web Services was launched for their own use, but then they started to realize the power of cloud computing and they started providing new services in their own domain. And who are the top 5 cloud computing providers? Obviously, AWS, Azure, Google Cloud, Alibaba Cloud, and the IBM Cloud. And you can clearly see the market share of AWS, which is Amazon Web Services. It's holding 34% of market share, and it's a 200 billion cloud market. It's huge market. So this was a pretty old figure. This was a figure of Q2 in 2022. The latest, which says 203 billion. But in Q3 2022, this has increased to 217 billion. That was a drastic change, and you can clearly see the growth in cloud. So it's so obvious that we are in need of manpower, and we need to equip ourselves and our students and to better cater to this market and make use of it. And key milestones in cloud computing, there are 100 zettabytes. That's the total volume of data that will be stored in cloud by 2025, which accounts for obviously 50% of all the data in the world. So that's going to be stored in cloud by 2025. So these figures, these are the statistics which are time and again telling us how important it is to start learning cloud computing. And to add on, the key effects of COVID on cloud use and adoption. So 87% of employers will speed up their cloud migration due to the pandemic, because maintaining a data center on their own without people was very tough for them during the pandemic. But if they migrate to cloud, it will be offered as a service to them by some other provider like Amazon Web Services or Azure, so that they don't need their employees to come to their data center, manage it, and maintain it. And 70% of employees are excited about the change in their jobs due to pandemic. For example, the remote work. So these are the factors which are really driving this cloud adoption and migration crazy. And these are some key cloud statistics. As you can clearly see, SMEs, the subject matter experts, are adopting cloud faster than ever since 2021. And you can see these stats speaks for themselves. I don't have to speak or elaborate much on them, but $7.3 billion, that is the Indian expenditure on public cloud by 2022. So these are all huge numbers, and this is the right time to learn cloud as well. A few more numbers I want to share to help you tell the growing pace of cloud adoption. So in last 3 years, so this is the end user spending forecast. It's in millions. All these numbers are in millions of US dollars. You can clearly see that the cloud business process services, application infrastructure services, cloud management and security services, software as a service, everything, desktop as a service, everything is drastically increasing. There is no point of going back from this. It's only going to get better. So the cloud professionals are in high demand, and as the resilience on remote access continues to grow, so will that need for talented IT experts with specialized cloud computing skills. Back in April 2022, Gartner published a report estimating that global end user spending on public cloud services in 2023 will reach $600 billion. So for the sake of comparison, it was 410 billion in 2021. And infrastructure as service is expected to grow the most, with spending increasing by 30.6% in 2023. And this is largely due to the post-COVID-19 explosion of hybrid and fully remote work arrangements. Back in February 2022, Grand View Research, they published a study of emerging trends in cloud computing space that estimated about 1.6 trillion in revenue will be generated across the entire cloud sector by 2030. More than half of the market will consist of banking, financial services, insurance, IT, telecom services, and consumer goods. It includes retail as well. So these figures are very promising. And this is just another reason how in the slide you can see how business leaders see the cloud usage in coming years. 50% of employers expect higher than normal cloud usage. Everything leads to one point that we are in need of people who know cloud, who can work in cloud technologies, who can embrace the change, and you can quickly adapt to the change, and who can help the organization in their journey towards the cloud migration. And there are obviously some challenges as well. And you can see the top 5 cloud security challenges: misconfiguration of cloud or wrong setup, and unauthorized access, insecure interfaces, external sharing of data. So these are very common and still persisting cloud security challenges. So more than the adoption itself, these security challenges also adds on to the demand of people skilled in cloud computing. And what's the top cloud issue today? So 75% of enterprises and 90% of security experts, they agree that cloud security is their top concern. So obviously it comes to a point that cloud is not just cloud computing, it's cyber security, it's connecting to Internet of Things. So if you have to survive in an IT industry or a non-IT industry as well in some cases, you will have to at least learn one cloud provider. It might be AWS, it might be Microsoft Azure or Google Cloud Platform or Oracle Cloud or IBM Cloud or Alibaba Cloud, anything, it may be anything. But I would preferably go with Amazon Web Services because they hold a huge market share, even in terms of end user usage or enterprise adoption. So I would strongly recommend you mentor your students to learn Amazon Web Services or Azure or cloud, any one cloud provider. It's the concept is all the same. It's only the terminologies that differ. So if they call a server as a virtual machine in Microsoft Azure, that would be called as EC2 in Amazon Web Services. So they don't have to learn all 3 or all the different cloud providers, but they just have to learn and get certified in any one of the cloud providers. That would be really, really useful for their career. Yeah, and top operational barriers. This is again, if you these percentages again shows you how a lack of human resource or expertise is stopping organization to move forward with their public cloud adoption. So all the data points to lack of human resources. If you can see, there is a 43% of lack in human resources or expertise for cloud computing, and they are searching for talented people in cloud computing in every industry and every sector almost. And so for public cloud projects, that this is a survey from people who have already adopted cloud, and you can see for the public cloud projects that respondents have completed, did they perform better or worse than expected according to the following measures. So you can see 45% of them have told they have greater security, better than expected, and 53% have told it's as expected. So only 2% of people don't agree that cloud adoption is good for the market or good for the industry. So all the figures, you can see only 1 or 2% of people think otherwise. rest 98% of them think cloud adoption is going as expected or even better than expected. You can see the last row here, immediate cost reduction. So cost cutting is across almost all the industries and all the companies nowadays. And when cloud can improve your cost cutting by 76%, why not? Who will stop themselves from migrating to a cloud from a traditional infrastructure? So these are some figures which are very promising. And yeah, and I did some homework before preparing for this presentation, and that was checking the latest Anna University syllabus. I should say I was really impressed with how updated is it to current industry needs and how well can students make use of their time in college, particularly the fifth and sixth semesters in college to prepare themselves for the industry needs. And I was really amazed by the fifth and seventh pages of Anna University syllabus, which I think I can share here. Let me try. Could you please confirm if my browser is visible now? Or is it still there?
Still in the PPT, sir, Anna University syllabus page.
Okay, 1 second, ma'am. I'll just stop presenting and I will start.
Okay, sir.
Is my Google screen visible now, madam? Browser?
Now only presentation starts. Okay, sir. Visible,
Yeah,
sir.
okay. Right. So I'm just opening the BE undergraduate CSE syllabus. And if I go to the 5th page of it, you can see I was impressed by this in particular, the professional electives 1, 2, 3, 4, 5. And if you come to page 8, so, and I'm just doing search here for the word cloud. You can see, so there is a vertical for cloud computing, yeah, and cloud computing is here, and it cuts across full stack development, so cloud services management, so UI UX design, software testing, automation, and cloud services management, security and privacy in cloud. So you can see this syllabus is very well framed, and it's according to the latest trends in the industry. So it's up to the students to make use of this religiously. So if they do it, then it's going to only help them. So rather than just choosing an easy subject out of these electives, if they could choose any cloud, I would say any of these electives, they're all equally good. And any one elective which says cloud computing, that'll be really helpful. And this is the same for IT as well. I just took an example of IT, and it's all the same. And again, this is the latest syllabus. I say it's according to the regulations 2021. So it's not an old as well. It's very good. And same professional elective in semester 5 and 6. If I come to page 8, yeah, again, cloud computing, your cloud services management, software defined networks. So these are all these terminologies, as we saw, are based on industry 4.2 concept. So this is really very well framed, and if people can pick up these skills at their 5th and 6th semesters, they'll be damn sure that they can easily get through placements on or off campus. because I've been in interview panels for about 15 years now. And in all these years, whenever we go for an on-campus or an off-campus interview, this is what we look out for. Has any of the student gone above and beyond and done as external certification in any of the trending technologies or tools? So if our students can do this as part of their curriculum rather than spending an time outside their college time, if they can choose these electives, if they can do a certification in Amazon Web Services or Amazon and Microsoft Azure or Google Cloud Platform, it is definitely going to make them stand out of the crowd, which many students won't concentrate on. So nowadays people are more inclined towards behavioral improvements. They want to improve their English, their grammar, things like that. Yeah, they are equally important. But if you show technical excellence in these areas, it's definitely going to improve your chances of getting hired, because that's what the industry is looking for. Even if you are a bit less on English or your verbal or communication skills, that can be corrected with the 1 or 2 training. But these technical skills are equally important. And that's where our students who are from the rural areas miss out. So again, this is where you can help by really getting into the syllabus and guiding them with right courses in terms of electives. So I'd be more happy if these subjects, these topics are part of the mandatory curriculum, but still it's very good to have it as elective as well, because those other curriculum you see here, this computer networks is there, full stack development, web development, distributed computing, all these things, IoT is there. So these are all going to be the building blocks of what they can learn as part of their professional electives. So this curriculum is very good, and it's up to the students to make use of it, and teachers like you to guide them into the right electives. I'll stop this screen and I'll go back to the presentation again.
Okay, sir.
Just let me know when you can see my presentation screen again.
Yeah, the PPT is visible, sir.
Okay, madam, thank you. Okay, I'll proceed with other slides too.
Okay,
I have only just 8 more. I'll quickly finish. Yeah, so what skills do you need for cloud computing? This is a burning question. The top cloud computing skills in demand as of now, they include cloud migration and deployment engineers, machine learning and artificial intelligence. And again, don't get too much carried away by ML and artificial intelligence. It is still an emerging field, and not many jobs have come up on machine learning and artificial intelligence. Though there is a lot of fuss about ML and AI, the job market for these two tech is relatively low when compared to cloud. So you can guide your students to better start with a cloud provider. Learn either AWS or Azure or GCP. So that will lay a foundation for them to improve on with ML, AI, and other skills mentioned here. And database skills, when I say database, very basics of database. You don't have to be a database expert. And programming languages, any one programming language is enough. It can be .NET, it can be Java, but they should, rather than being a jack of all trade, they should be king of one, so that they can lead. They can learn on other technologies on a high level, but they'll be strong on their own programming languages. As I said, developers who know cloud are of high demand, but developers who doesn't know cloud are not getting hired these days, know Java, .NET, and three other technologies, three other programming languages, they don't get hired. Rather, a person who is having one programming skill set and who is also certified in AWS or Azure, he gets hired quickly, just like that. And DevOps is another emerging field, and it's very good. That's where I am working on. And what is the best AWS certification? So the foundational certification of AWS is AWS Cloud Certified Cloud Practitioner. That is very basic. From here, you can take additional levels of certification. For example, they can begin with AWS Certified Solutions Architect. This will be more like an architect and administrator role, and AWS Certified Developer. So this is where the certification of a developer comes in. People who are well versed in Java or Node.js, they can go for this. So that they know how the underlying cloud platform works, where they are going to develop their application. And there is a very good certification called the Certified SysOps Administrator. This is kind of a hybrid of both these two. Then again, these are at associate level. Associate level is the very basic level of certification. Then comes your professional level. All these associate level certificates are valid for 3 years, I think. And after 3 years, you will have to recertify and renew the certification, because they will be adding multiple new services in the span of 3 years, and they expect you to know the new services as well. So these certifications expire every 3 years. And the professional level of certifications are a bit advanced. Once you finish these certifications, you can go into professional certifications. Out of these professional certification, I would suggest DevOps Engineer, AWS Certified DevOps Engineer. That's a very good certification to go for. And apart from these, we have this specialty certifications. For example, if your student wants to become a data scientist, something related to big data, then this is the course for the AWS Certified Big Data. Then if he is a geek and he already knows networking, he has done some course like CCNA or certifications like that, then AWS Certified Advanced Networking can be a very good choice for them. And always, irrespective of where, which domain you work on, you may be a developer, you may be an admin, even a non-IT, this certificate is very, very in demand, so much in demand. AWS certificates, certified security. Yeah, so these are pretty much things I thought of sharing in terms of certifications. But how long, you'll have an obvious question, right? How long will it take to learn cloud computing? It all depends on your current level of knowledge within cloud computing. To obtain a certification in cloud computing, it can take as long as an year. However, there are many accelerated programs that you can take as little as 2 months, I would say. So IT student can learn and get certified in cloud computing in a matter of 2 months. A non-IT student can do it in a matter of 3 months. That's the difference. Because nowadays, all the content in these platforms, like learning platforms, like Udemy, a Cloud Guru, a lot of videos are there available online, and these students have to just spend 10% of the time they spend on social media. That's it, and they can easily get certified. And you can also talk more about these kind of certifications and the value they bring into the students during your lectures or your day-to-day interactions with students, so that they slowly get to realize the benefits of doing these certifications when they are part of the college education as well. And you can also tell them to at least create an account and log into LinkedIn rather than Facebook. So that's definitely going to help them in terms of knowing the industry trends, what tech is evolving, what is it going to be in next 4 years or 5 years. That will give them visibility, and you'll see a lot of tech-related posts in LinkedIn. I personally learned a lot from LinkedIn posts, so it's not just a job portal anymore. LinkedIn is a wealth of knowledge. And what does a cloud software engineer do? So a cloud engineer is an IT specialist who handles all cloud computing duties, including planning, design, deployment, maintenance, and support. Most cloud engineers have experience in developing and designing additional cloud-based web services. And what does a cloud architect do? A cloud architect is an IT specialist responsible for deploying and overseeing a company's cloud computing strategy. So it's a bit on a higher level. This includes cloud adoption plans, cloud application design, cloud management, migration, and monitoring. And this is an interesting chart which I took from the internet. Like we have periodic tables in chemistry. They have even created a periodic table for the tools in DevOps. So such is it's a huge number of tools. It's a mixture of open source tools which are free to access. It comes free of cost. You don't have to pay anything. Just install it on your computer. For some, in some cases, not even installation, just web version will help you. So your open source, free, premium, paid, enterprise. So it's all in there. So if you are if your students are equipped in at least 2 or 3 of these tech, they'll be easily absorbed in a recruitment process. So I'd strongly recommend they try to learn at least 1 or 2, if not many of these tools. That would definitely be helpful for them. As I said, IT or non-IT, that doesn't matter. Begin with the cloud computing platform. Then if you want to go into IT, then these are the tools probably you would look out for as part of this Industry 4.2 adoption. And evolution of tech, I said, when I said evolution, these new techs, I just wanted to give you a quick example of how this tech has evolved. In traditional deployment, if you see, there will be a hardware. This will be our server. Okay, yeah. So this will be the hardware. That would be your server on which your operating system will lie on. Then the developers used to build app 1, app 2, app 3 and host it on their operating system. But then came this virtual machines where the hardware is there. You install an operating system on the hardware. Then you install another layer called hypervisor, which a famous hypervisor is VMware. So if you install VMware, then you can create virtual machines on them. So this was seen as a top technology some 5 or 10 years back. But now that's even outdated because even your virtual machine has to have its own operating system, its own binaries and libraries, and the app host at the top of it. Still, this will require a lot of resources for each virtual machine. So now comes the container deployment. So all your servers are replaced by containers. So what that means is a hardware will be there. Still, the hardware remains the same. Let's say this hardware has about 20 GB RAM and let's say 1 terabyte of storage. So the same hardware across all these deployments will be there. But on top of the operating system, you will be installing a container runtime engine. And the container runtime engine, you can deploy a container which will have only the specific binaries which is required to run this application. So in normal traditional deployment and in a normal hypervisor-based deployments, when you spin up a virtual machine, you required or not, this operating system will have a games folder, which no one never uses on a server operating system. But still it's there and it's consuming some resources and people would be storing some data in it. So there is a whole lot of resource wastage in this model. So this containerized application will have exactly and only the libraries and binaries required for this application to run. So this application is called as a microservice. So as I said, with my Amazon example, this application here, this can be one feature. This can be your Amazon search feature. This application can be your Amazon add to cart option, and this can be your payments gateway. So if you want to upgrade, you just need to bring down this microservice, do the upgrade or do the maintenance, and bring this container up. While these two containers will still be running, and the end users can still be accessing it. So there is no downtime at all. So this is a very small example I wanted to share. But when you think of the latest developments, it's even these tech, these containerization and Kubernetes or all this new tech can quickly go away in a matter of 4 or 5 years, I believe. But such is the speed at which the tech is evolving. And this is just another motivation for students. The average cloud computing career salaries, you can see clearly the cloud architect, he gets around on an average $138,000 a year. Likewise, the cloud data scientist, cloud consultant, cloud engineer. So all these are new job titles that has evolved over a period of last 6 to 7 years, and they are very good paying jobs. And you'll get to learn a lot, and the students' CV will be more heavy, and they'll be easily employable. This is just another motivation for them to spend some quality time. Even I am spending 2 hours in every week to learn something new. So if family men can do that, why not the students? They have to, and they should. They can. And these are some job titles, roles, and career pathing that has evolved as part of cloud computing. A cloud architect, a cloud security analyst, cloud engineer, DevOps engineer, also called as a platform engineer, or a build engineer, or a site reliability engineer. This is a very hot role in the market. A release manager or a data analyst, product manager. So it's a very diverse job, or the roles, I would say, which students can play based on their interest. It's not just an architect role. Even he wants to be a product manager, he can do that. Still for everything, your knowledge on cloud computing is the basics. That's the fundamental. And the future, yeah, as I said, just create once you go out of the session today evening or in the night, just create a Chat GPT account. Just try it out. That's going to be the next big thing. Because when I attended morning session, even engineer Jamin Santiago, he also covered on a high level about Chat GPT. He just has shown us a quick demo of what Chat GPT can do. He typed what is Industry 4.0 and it gave the answer. So that is only a tip of an iceberg. The potential capability of Chat GPT is that it could possibly replace a developer. If you just feed in the requirements of an application, Chat GPT can even give you the equivalent code for that application. So that's the level of algorithms they are feeding into this application. And that's why Microsoft has invested heavily on Chat GPT, and that's going to be the next big thing. So these are very compelling factors for us to upskill and cross-skill ourselves, because as I mentioned in that helicopter image, what seemingly seems to be very relevant today can be totally irrelevant in a matter of 2 or 3 years. So students can't really have their honeymoon period in the college. That too specifically in 5th and 6th semester. That's their turning point, I would say. And the market is very good. There are a lot of resources online, and people like us, we can help in guiding students in choosing a career, or we are ready to help as well. Any help which we can do, we are also ready to do. but it's totally up to the students to make use of this college and a good syllabus, the latest ununiversity syllabus. It's very impressive to help themselves into a better career. Yeah, thank you. That's all I had for today. Any questions?
Thank you, Gokul sir, for your innovative speech. Dear participants, if you have any queries, you may clarify now.
Sir, I'm really honored to. Yeah, I'm not going to ask you any questions, but I want to have something to be shared with you. I'm really very happy that your session is very interactive and interesting. That doesn't made us to feel sleepy or whatever. Because as you said, since AI is emerging technology, our curriculum has revised and updated with the newer technology, as you showed in your slide. Yes, that shows the implications of moving towards a newer technology. So generally, we need to update ourselves for the newer technology.
Yes.
Also, actually, to be frank, AI, Chat GPT, I've been recently, like today, I've just learned a lot from you. Also, you said about LinkedIn. Really, it's a fantastic platform, sir. We can share not only our knowledge, we can get more number of ideas and innovative things that even from students level to our working project level. I have also received so many things for my research work. So quite interesting. I'm happy that we should meet again in future and your FDPs.
Thank you. Thanks a lot, ma'am. Your good name? Sorry, I didn't see in the screen.
Sir, my name is Sharmila Devi, working as an assistant professor.
Okay, thank you, madam. Yeah, as you said, LinkedIn is the best platform, I would say, because in last 5 years, I've never logged into Facebook for more than an update or just a post for a year. And what that meant to me was that those 5 years, I was completely glued into LinkedIn. I got to know more about industry trends, what certifications I have to do, how can I make myself relevant to the industry, and how can I survive in the industry. So all this gave me an idea of what certifications to do and what to learn. And only based on this, my research and observation in LinkedIn, I did a couple of certifications. For example, Kubernetes certification or a cloud certification, which actually landed me a job in UK. So I was in UK for about 5 years earlier when I came back to India. But after my couple of certifications, I again got a job offer from UK. So I would say this is the kind of example people should take, and I'm a living example. I'm not boasting, but I'm just telling that rather than spending so much time in social media like Facebook or your Twitter, if students can really spend some time, at least 30 minutes of LinkedIn daily, it would take them to a totally different level which they can't imagine.
Thank you, sir. Thank you. Thank you so much, sir.
Thank you, ma'am.
Thank you, ma'am. Sir, the points you shared like key cloud statistics, cloud security, skills to be developed in the future are very informative and useful, sir. And you put a lot of efforts for this session. You referred Anna University syllabus of all the departments and you presented your speech to fill the gap between the curriculum and industry. I wondered about your dedication in preparing the content for this speech. When you called me at 8:30 a.m. this morning, I was surprised because it was 2:55 a.m. at UK. Also, you joined at the inaugural function at 9:30 a.m. and attended the full performance session. Really, I'm very thankful to have you as the eminent speaker of this session. Thank you very much, sir. Also, I thank Dr. Veer Chandra sir for attending the both sessions and Prakash Francis for attending this session. Both of them are the speakers for the next days. Thank you. Thank you. And dear participants, the feedback and assessment link will be posted in the chat box now. The link will be closed at 8 p.m. today, and kindly join at 9:45 a.m. in the same link for tomorrow forenoon session. Thank you all. Thank you.
Just one point before we close off, ma'am.
Yes.
I just thought of covering some areas on job opportunities abroad, but due to lack of time, I couldn't do it in this session. But probably I'm planning to do other sessions. As part of that, I can cover that and help the students, and they can feel free to.
Okay, sir. You are most welcome, sir. Thank you. Thank you, sir. Okay, sir. Okay, email you. All of you will.
Thank you.